Differentiation for physics. I will teach you some of my personal tricks about differentiation for physics. After watching this lecture, you will feel the real test of differentiation. First of all, let me teach you the basic concept of dependent and independent variables. Let's consider this algebraic equation y is equal to 2x. We know that algebraic equation is like a machine. We give some input to it, it provides us some sort of output. Let here I take two different values of x, like x is equal to 1 and x is equal to 2. Now I put this x is equal to 1 in this algebraic equation. I write y is equal to 2x or y is equal to 2 into 1. After calculation, I get y is equal to 2. Secondly, I put x is equal to 2 in this algebraic equation. I write y is equal to 2x or y is equal to 2 into 2. After calculation, I get y is equal to 4. From this example, I learned two important points. Firstly, I learned that when values of x change, values of y also change. Let me repeat it. When values of x change, values of y also change. For instance, we can see that when value of x is 1, value of y is 2. When value of x changes to 2, the value of y changes to 4. Thus we say that when values of x change, values of y change. Secondly, we say that x is independent variable, while y is dependent variable. I mean, we can take any value of x, but the values of y purely depends on x. Thus we say that x is independent variable, while y is dependent variable. Now I will teach you the super easy concept of differentiation, which is usually made very difficult. To understand this concept, we must understand the concept of slope. Remember that slope is nothing but it creates relationship between two quantities. For example, slope creates relationship between distance and time. We call this slope as speed. In physics, we usually study two types of slopes, average slope and instantaneous slope. First of all, we will learn the concept of average slope. Let's consider a cricket match between Pakistan and India. Let Pakistan score 100 runs in 10 overs. Now I am interested to find that how many runs are scored in each over. Let's consider this graph. To find total runs in each over, I find the average slope of this graph. To do so, I select 2 points on the graph. Let I select this point and this point. The x coordinate of this point is 5 and its y coordinate is 50. Similarly, the x coordinate of this point is 7 and its y coordinate is 70. Now slope is equal to change in y upon change in x. We can see that y changes from 50 to 70. So the change in y is equal to 70 minus 50 is equal to 20. While x changes from 5 to 7, the change in x is 7 minus 5 is equal to 2. I write slope is equal to the change in y is 20 runs upon the change in x is 2 overs. After calculation, I get 10 runs per over. It means that Pakistan scored 10 runs every over. Now we will learn the important concept of instantaneous slope. Let's consider this graph. Let the score of Pakistan is 75 runs in 7th over and 92 runs in 9th over. I am interested to find the score of Pakistan at 8th over. Let me repeat it. I am interested to find the score of Pakistan at 8th over. I mean, at the 8th over, the score changes from 75 to something unknown which we call del y. Now listen carefully. We know that slope is equal to change in y upon change in x. Here, the change in y is unknown, or del y, while the change in x is 0. Because I selected only one value of x, which is 8th over, so x does not change. Therefore, we say that change in x is 0. Hence, I write instantaneous slope is equal to change in y upon change in x, which is 0. We know that when we divide something by 0, it goes to infinity. It means that we cannot find the instantaneous slope or score of Pakistan team at 8th over. Remember that this was the biggest problem in mathematics, to find instantaneous slope. Now to solve this problem, the all-time students' favorite personalities, Newton Baba and Leibniz Baba, came and they solved this problem. They state that there is difference between del x is equal to 0 and del x approaches to 0. It means that when we write del x is equal to 0, it is 100% 0. But when we write del x approaches to 0, it means that del x is not 0, it is just living in the neighborhood of 0. Let me repeat it. Del x is not 0, it is just living in the neighborhood of 0. Here, Newton Baba and Leibniz Baba rewrite this del x. They say that at the 8th over, del x is not 0, but it approaches to 0. Thus, they rewrite this instantaneous slope as limit del x approaches to 0, change in y upon change in x. Here, this limit del x approaches to 0 means that the change in x is so small that it approaches to 0 or it lives in the neighborhood of 0. To simplify this instantaneous slope further, they rewrite dy by dx. They call it derivatives. Thus, derivative is nothing but the instantaneous slope of two quantities. Let me repeat it. Derivative is nothing but the instantaneous slope of two quantities. Here, we know that y is dependent variable and x is independent variable. This dy by dx means that the value of y changes with respect to x. Let me repeat it. This dy by dx means that the value of y changes with respect to x. Thus remember that derivative is the instantaneous slope of two quantities. Therefore, we will use derivatives to find the instantaneous score of Pakistani team at the 8th over. Hence noted down this basic concept of derivatives. Now I will teach you my favorite questions which I too often ask. What is the difference between derivatives and differentiation? Well, we know that derivative is the instantaneous slope of two quantities, while differentiation is the process to find derivatives. Secondly, why we need to study differentiation in physics? Well, to find instantaneous slope, instantaneous rate change, or instantaneous runs at a particular instant of time, we need to study derivatives. For example, consider this graph of a fast-moving airplane. Now using derivatives, we can easily find its speed at any time. Secondly, we can also predict its speed after 7 hours. Hence noted down these important questions. Now we will learn the easy calculation of derivatives. First of all, we will learn general rule or power rule of derivatives. For example, consider this question. Y is equal to x to the power n. Find its dy by dx. Well, I write dy by dx. We know that y is equal to xn. So I put the value of yn at. I get d by dx and to x raised to the power n. Now according to power rule, shift this power to the coefficient. Next, write the term as it is and then subtract 1 from its power. For example, I shift this power n to the coefficient. I write the term xn and then I subtract 1 from the n. Thus the derivatives of y is equal to xn is n into x raised to the power n minus 1. Now consider these questions and find their derivatives. In case of first question, the power of x is 2. I write 2, the term is x2 and I subtract 1 from it. Thus I get 2x. In case of second question, this 4 means coefficient of x. I write this 4 as it is. The power of x is 3. I shift it. The term is x3 and I subtract 1 from it. Here 4 into 3 is equal to 12 and 2 x raised to the power 3 minus 1 is equal to x squared. Thus I get 12x squared. In case of third question, this 6 means constant. Remember that the derivative of constant value is always 0. Let me repeat it. The derivative of constant value is always 0. Thus the derivative of y is equal to 6 is 0. In case of fourth question, this e is Euler number. Remember that the derivative of Euler number is the same. So I write ex. In case of fifth question, we will remember this trick. Whenever you see log x raised to the power 1, log x raised to the power 2, log x raised to the power 3, I always write 1 by x, 1 by x and 1 by x. Next, I shift these powers like 1, 2 and 3. These are the derivatives of log x raised to the power. In case of sixth question, these are the same type questions. The easy trick to crack this question is, I write the term as it is like ax, 2x and 6x. Secondly, I write its log base like log a, log 2 and log 6. Thus these are the derivatives of these questions. In case of seventh question, I always open this square root value. I write y is equal to x raised to the power 1 by 2. According to the power rule, I write 1 by 2 and 2 x raised to the power 1 by 2 minus 1. I get 1 by 2x raised to the power minus 1 by 2. This negative power of 1 by 2 means I have to shift x to the denominator. I write 1 by 2, 1 by x 1 by 2, or I get 1 by 2 square root x. Thus this is the derivative of square root x. Hence noted down these important concepts of power rule. Now I will teach you the super easy trick to learn derivatives of trigonometric ratios. First of all, I write these groups, group 1, group 2 and group 3. In the first group, I write sin x and cos x. In the second group, I write tan x and cot x. In the third group, I write cot x and cosec x. Now listen carefully. I put minus sign with all the trigonometric ratios starting with C, like cos x, cot x, and cosec x. In the first group, I draw these cross arrows. Thus the derivative of sin x is cos x and that of cos x is minus sin x. Similarly, in the second group, I draw these cross arrows. I write sec x and tan x. Secondly, I draw these two arrows from sec x. I write sec squared x and sec x. Thus the derivative of x is sec squared x. In the third group, I draw these cross arrows. I write cosec x and cotec x. Secondly, I draw these two arrows from cosec x. I write cosec squared x and cosec x. Now using this trick, find the derivatives of the following trigonometric ratios. Well, the derivative of sin x is minus cos x. The derivative of cosec x is minus cot x into cosec x. The derivative of tan x is sec squared x. Therefore, using this simple trick, we can easily find the derivative of trigonometric ratios. Now we will learn addition and subtraction rules for derivatives. For example, consider this question. Here, there are two terms in this question, 2x squared and 3. I will separately solve them. For instance, I write d by dx into 2x squared plus d by dx into 3. We know that the derivative of 2x squared is 2 into 2 into x raised to the power 2 minus 1 plus the derivative of 3 is 0. I get 4x. Thus the derivative of 2x squared plus 3 is 4x. Now consider these questions. Pause the video and try to solve them. Well, in case of first question, there are two terms. The derivative of x raised to the power 4 is 4x raised to the power 3 minus 1 minus the derivative of 3x squared is 3 into 2 into x raised to the power 2 minus 1. After calculation, I get 4x cubed minus 6x squared. In case of second question, I write 3x raised to the power 2 minus 1. The trick of log derivatives is easy. I write 1 by x. I shift the power to the numerator. Thus I get 3x squared plus 2 upon x. In case of third question, the derivative of sin x is cos x plus the derivative of 3x squared is 3 into 2 into x raised to the power 2 minus 1. After calculation, I get cos x plus 6x. Hence noted down these important questions. Now we will learn multiplication rules for derivatives. For example, consider this question. We can see that there are two terms, 2x and sin x. I call the first term as u and the second term as v. Now listen carefully. The most simple rule of multiplication is vd plus ud. I mean, I will write v term and I will derive the second u term. Next, I will write the u term and I will derive the first term. For instance, the v term is sin x. I write sin x. This d means derive the u term. The derivative of 2x is 2 into 1 plus the u term is 2x. This d means derive the v term. The derivative of sin x is cos x. Thus I get 2 sin x plus 2x into cos x. Hence this is the derivative of y function. Now consider these questions and find their dy by dx. Well, in the first case, let x cube is u and Ex is V. According to the multiplication rule, the derivative of y is Vd plus Ud. Here V is Ex. The derivative of x cube is 3x raised to the power 3 minus 1 plus the u is x cubed. The derivative of Ex is Ex. I get Ex into 3x squared plus 3x squared into Ex. Thus this is the derivative of y function. In case of this question, I rewrite it. Y is equal to x raised to the power 1 by 2 and to sine x. We can see that there are two terms, square root x and sine x. Let u is square root x and v is sine x. According to the rule of multiplication, y is equal to Vd plus Ud. Here v is sine x. The derivative of square root of x is 1 by 2 into x raised to the power 1 by 2 minus 1 plus the u is square root x. The derivative of sine x is cos x. As a result, I get sine x upon 2 square root x plus cos x into square root x. This is the derivatives of y function. Hence noted down the derivatives of multiplication. Now we will learn division rules of derivatives. For example, consider this question. We can see that there are two terms, cos x, which I call u, and x, which I call v. First of all, I write the multiplication rule which we already learned. Vd plus Ud. Now I change this plus sign to negative and I divide it by v squared. It means that write the v term and derive the u term minus write the u term and derive the v term upon v squared. For instance, the v term is x. I write x. This d means derive the u term. The derivation of cos x is minus sin x. Minus the u term is cos x. I write cos x. The derivative of x is 1. Upon the v term, which is x, I write x and I put square on it. I get minus x into sin x minus cos x upon x squared. Thus this is the derivative of y function. Now consider this question and find its derivative. Well, the u term is x squared plus 3 and the v term is x. According to the division rule of derivatives, it is equal to Vd minus Ud upon v squared. Here, the v is x. The derivation of u term is 2x plus 0 minus the u term is x squared plus 3. The derivative of v term is 1 upon v term squared, which is x squared. I get 2x squared minus x squared minus 3 upon x squared, or I get x squared minus 3 upon x squared. Thus the derivative of y function is x squared minus 3 upon x squared. Hence noted down these important questions. Lastly, I will teach you super easy trick to learn chain rule. Believe me, a lot of students make blunders while using chain rule in trigonometric ratios. It is because they do not understand the core concepts. First of all, we will learn some important concepts so that you must avoid all these mistakes. For example, I always teach that there is huge difference between y is equal to sin x and y is equal to sin 2x. I say sin x is like a machine. Let here the value of x is equal to 90 degree. Now this machine of sin x will process this 90 degree value and it will give us 1. Hence sin x is one machine. Secondly, sin 2x has two machines. One is smaller machine which is 2x and the another is larger machine which is sine. Let here the value of x is 90 degree. The smaller machine will process it. 2 into 90 degree is equal to 180 degree. After processing, the smaller machine will pass this value to the larger machine. Now the larger sine machine will process it and it will give us 0. Thus I say sin x is one machine and 2 is smaller machine inside bigger machine. Now listen carefully. If there is one machine, I will directly find its derivative. Like derivative of sin x is cos x. But if there is a smaller machine inside a bigger machine, I will use chain rule. Let me repeat it. If there is a smaller machine inside a bigger machine, I will use chain rule. Thus for the derivatives of sin 2x, I will use the chain rule. I write d by dx into sin 2x. First of all, I highlight the smaller machine. Here, the smaller machine is 2x. So in the first step, I multiply the derivative of y by d2x upon d2x. I write d by dx into sin 2x into d2x upon d2x. And the second step, I interchange the denominators. I write d by d2x into sin 2x into d2x upon dx. Here, we derivate only bigger machine with respect to smaller machine. I mean, the smaller machine 2x and 2x are the same. So I only derivate the sine machine. We know that the derivation of sine is cos. I place the smaller machine as it is, which is 2x. Secondly, the derivative of 2x is 2 into 1. I get 2 cos x. Thus the derivative of sin 2x is 2 cos x. Now consider these questions and find their derivatives using chain rule. Well, in the first case, I write d by dx into cos x squared. Here, the bigger machine is cos and the smaller machine is x squared. According to the trick, I solve this question in two steps. In the first step, I multiply the function by dx squared upon dx squared. I write d by dx cos x squared into dx squared upon dx squared. In the second step, I interchange the denominators. I get d by dx squared into cos x squared into dx squared upon dx. Now the smaller machine, x squared and x squared are the same. I just derivate the cos. The derivative of cos is minus sine. I write the smaller machine x squared. The derivative of x squared is 2x. I get minus 2x sine x squared. Thus the derivative of cos x squared is minus 2x sine x squared. In case of this question, I write d by dx x plus 1 whole squared. Here, the smaller machine is x plus 1 and the bigger machine is square. In the first step, I multiply the function by dx plus 1 upon dx plus 1. In the second step, I interchange the denominators. Now I write this power 2 as a coefficient and 2 x plus 1 raised to the power 2 minus 1 and 2 the derivative of x is 1 plus 0. I get 2 into x plus 1 or 2x plus 1. Thus the derivative of x plus 1 whole squared is 2x plus 1. Finally, consider this question. Pause the video and try to solve it. Well, I write d by dx into x squared plus 1 raised to the power 1 by 2. Here, the smaller machine is x squared plus 1 and the bigger machine is 1 by 2. In the first step, I multiply the function by x squared plus 1. I write d by dx x squared plus 1 raised to the power 1 by 2 into dx squared plus 1 upon dx squared plus 1. In the second step, I interchange the denumerators. I write d by dx squared plus 1 into x squared plus 1 raised to the power 1 by 2 into dx squared plus 1 upon dx. I get 1 by 2 into x squared plus 1 raised to the power 1 by 2 minus 1 into 2x raised to the power 2 minus 1 plus 0. This 2 and this 2 are cancelled out. I get x upon square root x squared plus 1. Thus this is the derivative of square root x squared plus 1. Therefore, using these simple methods, we can easily master differentiation for physics.